Hello, everyone, and thank you for joining. We'll begin in just a few moments. Hello, and welcome to today's Smart Manufacturing webinar, Cloud-Enabled Big Data Analytics for Semiconductor Manufacturing and Test. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You've joined the presentation listening using your computer speaker system by default. If you'd prefer to join over the telephone, just select phone in the audio pane and the dial-in information will be displayed. You'll have the opportunity to submit text questions to today's presenters by typing your questions into the question pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of the presentation. Today's webinar is being recorded, and you'll receive a follow-up email within 24 to 48 hours with a link to view the recording. I'd now like to introduce your presenter for today's webinar, Jason Arp, Senior Manager for Exensio Applications at PDF Solutions.
Thanks, Cheyenne. So before we get started, I am obligated to say that PDF is a public company. So this presentation does contain forward-looking statements. So keep that in mind as we go through the presentation today. And good morning, everyone. Thanks for joining us today as we continue our webinar series on smart manufacturing. Today we'll talk about how PDF is using its turnkey cloud-enabled big data analysis platform to help our customers implement smart manufacturing. We'll hear from two customers on how PDF Cloud is just as applicable for fabless startups as it is for large IDMs. And we'll also talk about what PDF's doing to keep all of your data safe and secure, and why cloud makes sense now more than ever, really, for all of us working from home. So again, my name is Jason Arp. I lead one of the field application teams here at PDF. I started my career in the late 1990s. I've been working with PDF software since 1998. And I joined PDF about 19 years ago. I'm pleased to say I'm joined by Dr. John Walsh, Senior Vice President Operations of Graphcore, Matthew Harris, Product Engineer, also from Graphcore, and Glenn Magnuson, Senior Manager, Product and Test Engineering from Skyworks Solutions. So throughout the presentation today, you'll hear me refer to PDF Cloud, which is PDF's full turnkey hosted environment that we've built using industry-leading technologies in partnership with best-in-class providers. So let's start with the Exensio Analytics platform. Really at the core of the PDF Cloud is Exensio Analytics. And really the cornerstone or keystone of everything we do at PDF and in Exensio is this embedded PDF domain knowledge. We're not just building software, we're users of our own software working with customers to solve complex problems. All of this is built on a fully scalable big data analysis platform. To put that in perspective, many of our customers count their databases in the hundreds of terabytes today, with scalability, well beyond that figure. Couple that with unique data types that PDF provides. Again, using our expertise, we've developed a number of unique data types enabling deeper insight into fab, assembly, and test equipment data, as well as product and process characterization data using PDF's test vehicles, and even field data using our CV Core technology. Layered on top of that is a rich set of machine learning solutions, many of them enabled by cloud technologies. All of that fed by a complete end-to-end the most comprehensive suite of end-to-end data compatibility in the industry. So if we take a closer look at that end-to-end data management component, the Exensio big data environment, captures all of the data types that you see here, from design all the way through sort, final test, as well as in-field monitoring. All of that's stored in our complete end-to-end analysis-ready database, which leverages, best-in-class cloud technologies accessible from anywhere in the world. We make use of lightweight, thin client protocols, which reduce latency, provides the same user experience anywhere worldwide. And layered on top of that are, rich cloud-enabled machine learning driven analysis, never before possible at a production scale without these cloud technologies. Another cornerstone of how PDF is enabling smart manufacturing for our customers is by use of our data exchange, or DEX network. DEX is a bidirectional data information conduit, which enables faster and secure access to your data. It provides more complete data, having already been enriched at the source using PDF agents on equipment. And it also has the ability to push configurations, rules, models, etc., from the offline cloud back to your online systems. DEX is deployed at many of the top OSATs, can be embedded at captive sites as well, to provide comprehensive data collection of any data. All of that being fed back to PDF Cloud in native PDF formats, enabling automatic routing, rapid ingestion into our systems, feeding semantic models, in our database layer, making all of that data pre-summarized and available for analysis. And again, pushing configurations and rules and outlier detection strategies back to the online systems, all centrally managed from the cloud. So let's take a look at a specific use case. This really illustrates, PDF Cloud is not just a lift and shift of existing systems. PDF Cloud is from the ground up big data. Cloud technologies provide a high degree of scalability and burst capacity to enable true production scale machine learning and edge prediction capabilities. Right. So if you look at my example here, this is especially applicable for large, horizontal fabs where you might have thousands of products in a product mix. The ability to dynamically scale the infrastructure to dynamic workloads, be able to bring up burst capacity to do, model training, and relearning exercises, pushing those models out to the edge to inference engines, and then ingesting the results back into the cloud. Right, all of this just simply wasn't possible using a traditional data center method, and all of this can be done at a lower cost with a much higher degree of reliability using cloud technologies. So let's pause briefly for our first poll question, and that question is, what percentage of your organization's day-to-day tools are currently based in the cloud? While you're answering the question, if I had asked that question maybe even 2 years ago, I think the answer would have been very different. Even 6 months ago, I think we find companies were only starting to think about cloud. Many of the companies I've spoken with, we're seeing an inflection point towards the end of 2019. COVID, has become a major catalyst, I think, for many companies to jump in to cloud. We've seen a lot of interest in the first part of 2020, more so than the last 2 years combined. Just as a reminder, if you have any questions about anything I've presented so far, please type them in the question panel. We'll get to them at the end. So let's talk more about some of the benefits of PDF Cloud. I'm going to read a statement from InfoWorld from 2017, and they state that there's this 80-20 data science dilemma, in that most data scientists are only spending 20% of their time doing actual data analysis, with the majority of their time being spent on finding data, cleaning it, organizing. Obviously this is a very inefficient data strategy. This is especially true today with the diversity of data types, the amount of data. Now more than ever, we need a central big data system to manage all of this data. PDF Cloud, enabled by big data, uses semantic models to align that data, pre-summarize it, make all of it available and analysis ready so that your data scientists can focus on solving problems and not data management. And Exensio is more than just a data repository. We help you transform your raw data into smart data. Exensio is increasingly becoming an instrumental component of corporate data lakes. Our unique combination of big data technologies and semantic models not only yield a higher performance solution, but also higher quality data, and that translates to more immediately actionable results. So further evidence that PDF is more than just a data warehouse. Exensio is now being embedded on over 300 unique equipment and tool types and models. Everything from fab data tools to test data, assembly data collection tools. You can see all of the biggest platforms in the industry are represented. We're continually adding support for both new and legacy platforms. All of this data is being collected by PDF at the source to provide that enriched data format through our DEX network back to the cloud. And in my opening remarks, I described PDF Cloud as being turnkey. If you look on the left-hand side of this page, you'll see modern big data systems are increasingly complex. They require specialized skill sets to manage. PDF's uniquely positioned to provide a complete turnkey set of services to manage all aspects of the deployment, everything from setting up the system, doing all of the database maintenance, upgrades, system monitoring, and monitoring and maintenance of the data loading environment, which really is the majority of the effort in sustaining a system like this. Everything through qualifying and validating any customizations you might have done to the software. Right? All of this allows your engineers to spend their time on solving problems and not managing systems. So now let's talk a bit more about the scalability of the PDF Cloud as well as the Exensio environment. So really at the foundation of the Exensio big data system is our hybrid database model. It's built on a highly parallelized Cassandra and Spark platform for maximum scalability. Sitting on top of that is the Exensio user interface and automation layers. There's a desktop client that power users or content creators are able to create rich analyses in, as well as a web client for more casual users or content consumers to be able to consume that content. In parallel with that is an automation layer. This is really more and more becoming the core of our machine learning and advanced analytics framework. We've architected this entire system to support any size customer, from fabless startups focused on leading edge applications like Graphcore to large enterprise IDMs like Skyworks with a broad mix of both products and technologies. So if we compare Exensio big data to a traditional relational database deployment, and we do so using systems with the same cost, one of the key benefits to a big data architecture is, it can be enabled by commodity hardware. when we do that, we consistently measure 8x performance multiplier, both on data ingestion, or the ability to load data into the system, as well as working with that raw data, getting the data out of the system. The more exciting part is in the center box. This is our in-database analytics capabilities, built on top of Cassandra Spark. And here we're seeing 40x improvement on average. This can be considerably higher than that. This really enables you to tap into analysis capabilities that simply were not possible before the advent of big data. And PDF will continue to make significant investments in the Spark layer to more and more leverage the power of big data to do all the heavy lifting in your analysis. And all of this is made possible due to the highly parallelized and scalable nature of the big data architecture. So moving to cloud frees up, a significant amount of resources for customers, not just engineering resources, but hardware, IT resources, so that everybody can focus on more value-added tasks. It's usually a surprise to our customers how much effort is involved in actually supporting a traditional on-prem environment when you look at it holistically, like we're looking at it here. This example is just a high-level list of all the costs associated with a traditional on-prem data center deployment. Customers who move to the PDF cloud, are able to enjoy a turnkey environment for engineering that can be brought up quickly. Again, so you can focus your time on essential engineering tasks, and letting PDF manage all aspects of the system for you. So from a cost savings perspective, let's take a look at a typical total cost of ownership analysis. So here's an actual customer example of the types of savings that the PDF cloud can achieve. So this was a customer that asked for an 8-year TCO. We always include one natural hardware refresh in a TCO scenario like this, which increasingly is becoming 5 years, if not more. Customers are holding on to their hardware for much longer than historically has been the case. So if you add up all of the on-prem hardware costs plus the PDF services that are necessary to support a big data environment, all of the data management and labor costs associated with sustaining a YMS deployment, as well as supporting that data center. If you contrast that with a fully turnkey PDF cloud site on the left-hand side, you can see that there's 36% savings, or more than $3.5 million savings over that 8-year period. This particular implementation was done on Amazon Cloud Services. Both Graphcore and Skyworks are also implemented on Amazon Cloud. And one final point, as we add more tiered storage support for the platform, we expect to deliver an additional 10 to 40% cost savings in that data storage tier for data that's accessed perhaps less frequently, or additional history that needs to be kept online. So if we take a look at an actual case study then from another customer, if we take a look at the problem statement, this customer has hundreds of users all over the world, typical fabless data sources. Of course, their challenges were around alignment of all of the data, and everybody's global these days, right? Distributed IT teams, multiple silos of data and support resources, right? So by moving to manufacturing analytics on PDF Cloud, they were able to overcome all of those challenges. And this particular customer made a 10-year commitment with us on PDF Cloud. So, this is evidence that customers see PDF and the cloud as very strategic, and they're making long-term investments with us here. So bottom line, this customer was able to save more than just the IT hardware cost savings, but $8 million a year in productivity gains as a result of these hundreds of users having access to this end-to-end analytics, centrally managed by PDF. So let's pause for another poll question. And this poll question is the performance or capacity of your current analytics solution negatively impacting your productivity? So while you're answering that, think about how much time you spend finding, extracting, transforming, aligning your data, manual cleanup necessary to make all of that data analysis ready. And again, don't forget, if you have questions about anything that I've presented so far, please type them in the questions panel, and there'll be a Q&A session at the end. Leave the poll up for another few more seconds. Okay, thank you. All right, let's spend a moment and talk about what PDF is doing to keep our customers' data and information safe, secure, and always available. So here's data provided by the lead cloud provider, Amazon, which backs up what we see in the field as well, which is cloud is measurably superior to what is possible in traditional data centers. Right, cloud provides best-in-class hardware and software support. Gone are the frequent refresh cycles of hardware and the downtime associated with that. And you tap into all the cloud-native, high availability technologies so that all of these services are up uninterrupted 24/7 to support your organization. Final poll question. Is cloud data security a significant concern for you or your organization? So one of the concerns that we've heard from customers historically is that cloud cannot be as secure as our on-prem environment. But more and more companies, I think, are realizing the maturity of the top-tier cloud providers that we partner with, and the amount of investment by cloud companies in info security. It's just not possible for individual organization security teams to compete with that these days. Okay, thank you. So I've got a couple more slides. Let's talk just a moment about security and privacy in PDF Cloud. So we take our customers' data security and privacy very seriously, right? We employ industry best practices with how we deploy and how PDF and our customers access the cloud. We limit the attack surface by limiting the public access to the cloud. We use independent third-party attack testing on all of our cloud sites. And the cloud is centrally monitored with 24/7 monitoring. All access is logged and audited. You can see every customer's cloud site is deployed in an isolated network, no resource sharing. Everything is dedicated to an individual customer. Okay, let me just briefly summarize some of the statements that I made today, and then I'm going to turn it over to our friends at Graphcore. So again, full turnkey platform. PDF does all the setup and maintenance. Customers can focus on solving engineering problems. PDF Cloud equals big data, which is higher productivity for users, especially when you're working from home. PDF Cloud can save your organization money. It scales with your business. And finally, we can get a system up and running quickly so that you can start realizing the benefits of PDF Cloud immediately. So with that, I'm going to turn it over to John and Matthew at Graphcore. And again, if you have any questions, please type them in the question panel, and we'll get to that during the Q&A session at the end. Thank you.
Great. Thank you, Jason. So first of all, I'd like to thank our friends at PDF for inviting us to present today. It's really very nice of them. So what I'm going to do is I'm going to just introduce Graphcore. Matthew is going to show you some of our use cases, but I'm also going to respect the fact that my bandwidth may be limited, so I'll turn off my camera for most of the presentation. I can come back on at the end for questions, okay? So here goes. So Graphcore, a 4-year-old company. The foundation of our IP is really our intelligence processor unit. We have a team of 400 people globally, and much of what Jason was saying kind of resonates. You know, it's an expensive business that we're in, and we've got good investors who've come and supported us over the course of the last 4 years. We've raised 450 million to fund the company in the course of the last 4 years. If you advance, Jason. So we're headquartered in Bristol, which is about 2 hours to the west of London. I'm speaking to you at the moment from Ireland. You know, everybody's working from home, right? And Ireland is my home, but I work in Bristol, as does Matthew, who'll talk to you later. We've got a mini operations team based in Taiwan. One thing, you know, that it isn't stated explicitly here today, all our manufacturing is in Taiwan. So we use TSMC 7nm technology, we use ASE for packaging, and we use a contract manufacturer as well in Taiwan to build an end system. So, you know, we don't sell chips, we sell end systems, and you'll see some of that in a minute. We've got business folks and customer folks in Beijing and on the West Coast and on the East Coast and in Austin, and also in Japan and Korea. Okay, you can advance, Jason. So the challenge that machine intelligence faces is that the model size for computational models that are deployed in machine learning is really growing exponentially. And because of that, the amount of compute resources are also growing, and it just follows the model size. You know, now people are talking about model sizes of hundreds of millions of parameters. And anytime you hear about parameters and model sizes, you know, it's computational workload. So model size goes up, computational workload goes up. And that's, if you advance, you know, that's where we believe our IPU really lets innovators create the next generation of machine intelligence. So we've just launched our Colossus Mark II device, which is the world's largest chip. It's 823 square millimeters in size. We've got 59.4 billion transistors, and it's built in TSMC's 7nm technology. So this also within the die, we've got 900 megabytes of SRAM within the die, and this enables 250 teraflops of AI float compute capability. You'll see a graphic of our chip in a minute, but we've got just under 1,500 independent processor cores, and because of the hardware workers that we've got in the processor cores, that enables us to have just under 9,000 separate threads operating within every die as well. Okay, you can step forward, Jason. So what? Our die is solving many challenges really. So one of them is parallelism, and we're able to manage this multi-instruction, multi-thread capability using our IPU, which is very important for graph computational frameworks. And we're also taking huge advantage of the amount of memory we can access for a given energy envelope. So, you know, if you've got a CPU with DRAM nearby and you're talking to that DRAM, you can access a certain amount of bits per energy envelope. The GPU concept with high bandwidth memory co-located on the package, you can access more. And with our device, we've got the processor cores and the memory on the same die. We get a big advantage there. So if you go on to the next page, Jason, you'll see a little bit of the footprint of our device. So as I said, we've got just under 1,500 independent IPU tiles, and each one of those is performing multiple threads, like I mentioned. We have co-located memory, so every core has an amount of memory neighboring to that core, and in total then that sums up to 900 megabytes of memory on one chip. We've got an exchange fabric within the die, so once the processing task is completed by one core, we can pass it to any other core within the die. And we've got interfaces, we've got standard PCIe interfaces to talk to the host computer, and we've got IPU links as well that allow us to hook different numbers of our chips together. So depending on the model size, you might use more than one of our die. And that's kind of nicely teeing up where you were going next, Jason. So our products, we use this to people who aren't familiar with the semiconductor industry, really. If you look at the bottom of the slide, so we're taking one of our devices and we're putting it into, we're putting 4 of them into what we call an M2000, and then we're developing our platform so that we can instance, or so that our customers can instance out pod 64s. So an M2000 is 4 of our devices, a pod 64 has 64 of our devices therein. Maybe just go to the next page as well, Jason. So you'll see on our website pictures of our recently released M2000. And this is where the numbers really grow and grow and grow. So, the one of these devices, as I said, has 4 of our Mark II Colossus devices, each with 59.4 billion transistors. We've got 900 megabytes of SRAM in each device, so 3.6 gig of memory in the device alone. And if you stack 16 of those then to build a pod 64, we're able to deliver 16 petaflops of AI compute. We've got 7.2 terabytes of memory. We've got these really large capabilities that we're able to give to our customers. And one of the things that Matthew will show you in a minute is how we're exercising the data that we get from the various parts of our manufacturing. So you have to think about the scales that we're talking about. Okay, 7 nanometer technology, very good. 59 billion transistors. So we look at very large die, 823 square millimeter die, but we look at sub die within each die at the scale of about 1,500. We've got subdivisions within those as well. So we're looking all the way down to the individual ring oscillators that describe the transistor performance in TSMC. We're looking at kind of standard yield metrics, and Matthew will show you a bunch of those. But we're also looking at how we scale out our technology across one of our M2000s, so 4 of these devices. But also on the M2000, we're looking at, we've got about 5,000 or 6,000 components on here. So, we've got of the order of tens of thousands of solder joints. We have an awful lot of data coming at us. And you'll see that, this is one of the reasons why the Exensio Cloud solution works for us. So with that, I'll hand over to Matthew and I'll wrap up at the end.
Hi, thanks, John. My name is Matthew Harris. I'm a product engineer with Graphcore. Just to reiterate some of the things that John has said, and also that Jason mentioned as well. As a new startup, a very young startup with limited resource, we did not have the desire or really the bandwidth to develop our own in-house yield management system, or to create our own database with all the database management, IT security, hardware, resourcing configuration that goes with it. So this was a reason why Exensio and the PDF cloud solution was so interesting to us. It allows us to step back from the data. This goes back to the sort of the 80-20 data analyst thing. We want to be able to step away from doing the 80% data wrangling to focus on the data analysis, and that's what the cloud has allowed us to do. So we have this, we have a flow setup, or that we're setting at the moment, that's sort of sketched out here, where we're pulling data from our OSATs via the PDF DEX system. And then all of the data loading, all of the database management is happening in the cloud, and our involvement in that is really limited to supporting the PDF guys setting it up, helping them understand our data structures, and once that's in place, it just happens seamlessly. So that's working very well. We have some novel data structures. As John mentioned, we have a lot of sub-die, and there are a lot of parametrics and test data associated with that. We have, at the moment, I think we're running at about 18,000 tests per die in our test program. So there's a lot of data to manage, and that's happening very well at the moment. We're also working on integrating data from process metrology. So as John mentioned, solder paste inspection, for example, and also board test data, which is very novel. In fact, the data structures don't exist. We're writing at the moment. We're working with PDF to make them as efficient as possible. So this is something new that for us, and to a certain extent, I think for PDF, because they are data structures that are very much unique to Graphcore. So yes, as well, the ability to access the data remotely from anywhere in the world, it's invaluable to us. As John mentioned, we have operation team in Taiwan. They can access the data as easily as we can. So that's great. Do you want to go on to the next slide? Just a couple of slides. So these are very straightforward slides. This is graphs very obvious to any product engineer. Wafer maps for parametric and bin yield. Nothing particularly groundbreaking, but Exensio makes this very easy. It was pretty much the first thing we could do on the first training session. We uploaded some data, and there you had wafer maps. So that's great. It gives us a very easy way of looking at spatial dependency of yield and parameters across wafers, for example. We can also reconstruct wafer maps based on data that is contained in our die, our Eve users, and Exensio just does it. So if we go on to the next slide, it's a little bit more interesting. Now here we get down into what John was describing as the sub-die level. So we go from having a wafer of several dozen die to a wafer of over 23,000 die, effectively, in terms of the amount of data we're getting. And again, we have parametric data, and we have pass-fail data, which allows us to look at our yield management and defectivity. Again, these were somewhat novel data structures. We've developed them ourselves to, in clever ways, we're compressing data to keep the test data file size down. PDF is able to import that without any problem. It's taken away a lot of manual data wrangling from our point of view. So that's at the those maps are at the sub-die level. As John mentioned, we have the plan to go down even further to SRAM cell level, transistor level, ideally. So this is in our plan. It also allows us, Exensio also allows us to see key parametric distributions and correlations. None of this is, again, particularly groundbreaking, but the sheer amount of data that we're getting out of the test program makes it very difficult to work with unless all the databasing is done in the background, and that's something that the PDF cloud has allowed us to do. The good thing about the PDF cloud, I was going to mention on the previous slide, it's allowed, because all the support work from the PDF guys, writing loaders, writing database schemas, is all happening remotely rather than on site. We've got access to these guys working, almost 24/7. There's always someone to support us. It allows us to make use of a much wider amount of resource at PDF than would be available if it was just on site, and it's worked very well. So if we go on to the next slide, we're also pulling in data from a wide range of different sources, from manufacturing, process control monitors. These are pretty standard control charts, but the data is integrated into Exensio with our product test data. So it's very easy to generate correlations between wafer level manufacturing data and chip test electrical data. And if we go on to the next slide, one of the great things, one of the first requests we had for PDF when we first started talking to them was we wanted to be able to track the history of a particular die. So if we have a strange test result at system level test, or there is some other reason we want to track the history of a die, we can just type in to Exensio the key identifiers, wafer, X and Y coordinates, and we can extract from that database a full history of that chip. Now, at the moment, it's mainly focused on electrical test data and wafer data. Eventually, it will include metrology data, chip manufacturing history, and board test data as well. So all of that will be linked and will be searchable. So you go on to the next page. So just a quick slide. We're integrating new data types, and these not very informative graphs are data from our solder paste inspection data that we've just started loading in the last few weeks. It allows us to get right into the detail of solder paste metrology at board level, component level, pin level. We're also looking at integrating some of the images that have been taken during inspections to extract data from that. And we're also implementing at the moment a DEX server at our our contract manufacturer for boards. So we'll be able to pull test data from our consigned testers at the contract manufacturer into Exensio as well. So that's it. So that's some of the examples, some of the data and the data types and the analysis that we're getting out. So I'll hand it back to John.
Thanks, Matthew. So we deploy cloud hardware. We use TSMC, we use ASE, we use contract manufacturer, we sell end product. So everything that Jason said earlier on really resonates very strongly with us. And it's one of the reasons that we chose Exensio and we chose Exensio for cloud with PDF is because we know the effort involved to build hardware, full racks and deploy and manage and upgrade large data centers. We have our own data center even for our own product, but we didn't see any value to do the same thing for the data that we're getting for our manufactured products. And we knew that, you know, we could rely on the PDF folks to just take that burden away from us. So we chose Exensio Cloud because it really meets our complex data needs. It's scalable. The capabilities, they just exist and they're proven. And over the time that we've been using it, you know, the performance is indeed proven, no questions. And the data types just get integrated without hassle. And everybody that's ever thought it was a good idea to build their own system or to write their own loaders knows the challenge is all in the loading. So, you know, these are the reasons that we chose to work with PDF and Exensio Cloud. That's it, Jason. We're done.
Great, thank you, John and Matthew. Just as a reminder, if you have any questions for John or Matthew, please type them into the question panel now. We'll get to those during the Q&A session. And with that, I'm going to hand the ball to Glenn Magnuson from Skyworks.
Okay, thank you, Jason, and hello, everyone. Yeah, my name is Glenn Magnuson, and I'm a senior manager at Skyworks Solutions. So why don't we just go ahead to the next slide? So I'll start with a little introduction to Skyworks. So we're a semiconductor company whose products are basically involved in all aspects of wireless communications. As you can see, we've got products that go into a number of different markets. And just for the sake of time, I won't kind of walk through all of those. We're a global company, which I think is important when we consider the Exensio or PDF solutions. And we've got locations kind of across different countries and continents. We do a lot of our own manufacturing and have factories in various locations in North America and Asia. But we also work with a number of subcons and suppliers. So it's kind of a complex environment. So if you'll go to the next slide, Jason. I wanted to give you a little background on our history with PDF solutions. I won't spend too much time on it, but we started using manufacturing analytics, which at the time was called Data Power, back in the 90s, and that's something I was involved with at the time. So I've got a long history with their products. After some planning and discussions that really started in 2018, we decided to deploy manufacturing analytics as a company-wide factory analytics solution in 2019. And as part of that decision, we decided to move from an on-premise model to the SaaS cloud-based solution. We kicked off the project April of last year. By somewhere in summer, we were loading data, doing testing, that sort of thing. And early in fall, we started training users. So overall, I would say, given the complexity of the project, we're pretty happy with that and think it went pretty quickly, really. One of the things to note, we did decide to set this up as a fresh system rather than trying to migrate data from existing database. And that really gave us an opportunity to make some enhancements in our data processing and just to get a clean start. So the way we did that, we had access to historical data as archive files. So we basically, once we were ready to go, we started with historical data and started loading that. And once it caught up to the present time, it just kind of switched over to loading current data. And that just gave us more data for the users at the point where we did training. So if you want to go to the next slide, Jason. So why did we decide to go with a SaaS cloud-based solution? Basically, we saw a number of benefits that we were expecting to get from the solution, and they're just kind of listed here. First of all, no need for us to set up and maintain the hardware, worry about upgrades, hardware replacement over time, that sort of thing. We didn't need to either add or use existing internal database administrator resources to support the system, which is important. Our resources are always pretty busy anyway. The cloud-based solution we felt would give us the ability to scale up or down as our needs changed. Historically, kind of for on-premise systems, and this goes back, decades with my experience, what we see is we'd set up the system based on what we thought we needed, and we thought we'd give it plenty of margin for growth and stuff. And then, before we knew it, we'd outgrow the system, and it was kind of a pain to move to a new system or upgrade or whatever. So the scalability was kind of an important factor. Another important factor was that we were expecting to see consistent user performance regardless of the location. And as we said, we've got people all over the world. And so that was an important factor. Also, how their computers, we got people with really good new laptops. We got people running on laptops that they've had for 5 years. That was kind of a factor too. When we did the analysis on the costs and we factored in upfront and future equipment expenses, the resources needed to support them, and all that sort of thing, our conclusion was that it was a much more cost-effective solution, and I think that just kind of echoes things you heard in the earlier presentations. Also, the redundancy and high availability of a cloud system were important to us. And then finally, we have a lot of users, and we felt that having a browser-based solution would really reduce the resources, or actually kind of eliminate the resources necessary to deploy the software to everyone. So, okay, so if you want to go to the next slide, Jason. So, so now I'll kind of get into some of the experiences we had getting started. And I do want to, I think it's important to kind of note that this was the first big cloud-based test data analytics system at Skyworks. It was the first cloud-based system I was involved with, and I think our IT folks maybe been involved with a few in the past, but nothing kind of like this. One of the things I think worked really great and enabled us to get up and running quickly was that PDF right away set up a temporary cloud environment that we were able to use for developing loaders, testing, even for my team to start learning the tool. And that all was able to happen in parallel to the production environment being set up. So I think that's good. The production environment did take somewhat longer than we originally had on the timeline, and I think that kind of came down to a number of different factors. One of them was the single sign-on took a while to get up and running. I think at the time it was maybe the first time our IT team were involved in doing that, or if not the first, it was one of the first. Since then they've done more, but that took a while. Around the time we started, PDF decided to change their target cloud provider. They mentioned that we went to Amazon. That was kind of the change, and we were very happy with that decision. But I do think it just the timing of it was a coincidence that kind of impacted the ramp up and getting the production environment started, just because that decision happened right around that time. Getting the security optimized and the performance, I think maybe took a little more time than we anticipated. On the performance, one of the things we spent a fair amount of time on was optimizing the data file upload performance, because we just have lots and lots of data. And one of the interesting things that that we ran into that kind of surprised me was we found out that it made a big difference whether we were uploading multi-file zips or individually zipped files. It turned out that for us, if we uploaded, let's say, 1,000 files in one zip, it was much faster than individually zipping and uploading 1,000 files. In our original model, we were just uploading individual files, so they were compressed, but still it made a difference. Ultimately, I think all of these things kind of fed back to the PDF team. They were involved in helping us address all of these things. So I think it probably resulted in some improvements in their infrastructure and kind of their standard deployment approach. So, okay, if you want to go to the next slide. So on this slide, I'm going to talk a little bit about some of the challenges that we ran into. And I want to say this isn't meant to be negative. Really, for us, this was a big change moving from on-premise systems to a cloud system. And so we ran into some challenges, and I wouldn't say that was unexpected. But I thought it would be useful to share these because I know there are probably some other customers out there or potential customers of PDF who are looking to go to it, and maybe this will help for you to see some of the things that we ran into. So I also want to kind of point out one of the things that I think was a factor here was that our IT security folks decided that they preferred a Citrix only solution rather than a VPN solution. And I think in hindsight, we realized that kind of maybe created some of these challenges, and that's something we may look at changing in the future. So first of all, one of the things that kind of caught us by surprise was that the Citrix environment has a download size limit. So as we started training users, we'd find they would go quickly create a gigabyte or multi-gigabyte PDF file or PowerPoint file and then not be able to get it down to their computer. So that was kind of one of the early bumps in the road that we ran into. We worked with PDF on that, and they came up with what I think was a rather clever workaround, which is that we gave the users a folder on the cloud where they could drop the files, and then those files would be automatically transferred down to a Skyworks location where they could get them. So maybe not the ideal solution, but the user seemed to be fine with that, so that worked well. Getting automated reports set up was a bit of a challenge, and again, it kind of had to do with the fact that we had basically a firewall between Exensio and the users. I think one of the options with automated reports is that an email goes out with a link. Well, the problem there is the link is not something that they would be able to click on and get directly to it. They would have to connect to Citrix and do that. What we ultimately did was kind of leverage the same automated download capability that we use for large files. So as we generate automated reports, we're generally sending them directly to a Skyworks location, posting them on an internal server or web server. Kind of similarly, what we wanted to be able to control the configuration of automated reports from applications running on our side, and that required PDF's help to set up essentially the reverse automated transfer, and that's working well now. And then on our list of things that we want to do that's not set up yet is to be able to connect some of our internal systems like CAD systems directly to PDF. That's something we're working on with PDF, and I know they've got an API coming out soon, so it's something that's in work. And then I think one of the last things to mention, or the last thing to mention here, we've been doing on-premise systems for many years, so we're pretty accustomed to, something goes wrong, we jump on, do it. It's just kind of a paradigm change for us that took a little getting used to, that we don't have the same level of hands-on and visibility to the data loading and other things. I think those are good things. It just was something that was a little different to us, and maybe we hadn't fully digested. But I do want to say that the PDF team we've worked with, they've always been great to work with and really quick to identify and resolve issues. So, okay, if you want to go to the next slide. So on this slide, I want to talk about some of the benefits we've seen by moving to a cloud-based solution. I think the short answer here is I think we got all of the benefits we were hoping for, and maybe then some more. First of all, from a IT and network resource perspective, getting it set up was pretty minimal. And from an ongoing perspective, we don't need to be doing backups. We don't need anybody who's doing a system admin role. There's no DBA activity, et cetera, for us. So all of those things I think are great. I think we've been really happy with the consistent performance and the user experience across Skyworks locations. I think one of the things that's really advantageous there is that the users don't have to, the first step isn't for the users to download a bunch of data to their computer and then start crunching it. Everything's happening in the cloud, and the process of getting the data from the database to the cloud system where they're analyzing it is really fast. A couple little caveats that I think I'll mention on performance, just because I think it's important to be aware of these things. First of all, if the user's got a spotty internet connection, which some do, we do see that the Citrix connection can drop. But the nice thing there is when they reconnect, it's still there. So whatever they were working on is still there, that sort of thing. And then the other thing, which I kind of mentioned before, our users have this tendency to create massive reports or files. And in that case, if they're on a slow connection, it ultimately will take time for them to get that down to their computer. But it's not, the WAN performance is really not a factor. It's really the internet connection, which I think is important. So I think in some cases, our locations have a good connection to the internet, and maybe the WAN is kind of busy because of a lot of other internal data transfers. And so I think that's helpful. Let's see, the performance and the user experience is really completely independent of the PC that the users are on. So we're no longer having to tell people who have older laptops or desktops that they should be begging their boss for an upgrade, which is something we've done for years. So I think that's great. And finally, I want to comment that I think deploying upgrades has been extremely easy. We've got a lot of users all over the place, different time zones and everything. So with an on-premise solution and local software install like we had before, doing those upgrades was a big project and a lot of work. Since moving to the Exensio or to the PDF cloud, all we really do is we test the new version. They basically set it up so we can test it without the users having access. We do the testing, we schedule the time, we let the users know, hey, we're going to do an upgrade, here's when, and PDF takes care of everything else. So that's great. Okay, Jason, if you want to go to the next slide. So PDF had suggested I talk a little bit about the impact of COVID-19 and how having a cloud-based solution has helped. So I'll talk a little bit about that. First of all, I think it was always important for us that the users have the flexibility to work from home when they're traveling or whatever. So that was kind of always part of the plan. And I think, you know, lately we have a lot more people working from home than we ever anticipated, and I'm sure that's true for every company out there. But I think it's gone really well. We haven't done specific data collection on this, but we're really not seeing any significant problems, or really not any problems. You know, we do have users who have really lousy internet connections. Actually, one of my employees does, and so they would occasionally, like I mentioned before, their Citrix connection might drop, or if they want to download something, that can be a little slow. But otherwise, I think really having a cloud-based solution has been really helpful. Okay, so if you want to go to the next slide. So really, this is my last slide, and then I know we go into the Q&A session if there's still time. Just kind of in terms of next steps, at this point, we're still adding data sources that have never been integrated into our data analytics systems before. So that's kind of our main focus. As we complete that and those activities kind of wind down, then I think we're going to be spending a lot more time exploring and deploying new capabilities from PDF. So I think there's a lot more that we will be doing in the future, and we'll continue to kind of expand as we go forward. So I think that's it. Thank you very much for your time and attention.
Great, thanks so much, Glenn. So I think at this point, I'm going to turn it back over to the moderator for Q&A. And just a reminder, if you have questions for Glenn, you please type those into the question panel now.
Thank you, Jason. So we're now going to be answering some questions submitted during today's presentation. And as you just said, as a reminder, you can still submit questions through the question pane of your attendee control panel. So Jason, our first question is from you, and our attendee writes, how is Exensio accomplishing complete die traceability in electrical testing from wafer to packaging? Are you using QR codes on the die to do that?
Pardon me, I was on mute. That's a great question. So there's a number of ways that we handle that. We do have complete die traceability in the schema that can be accomplished a couple of ways. If you have a device identifier that can be read electronically, we have a place in the database to store that. That information is cataloged and can be retrieved against. If you've got complex packages with multiple devices, perhaps passives, etc., our ALPS solution does have the ability to both write and read a 2D barcode on the package. That information can then be scanned throughout the manufacturing process and used to perform that full traceability in the event that you don't have an electronic chip identifier. So yes.
Thank you. And then I think we'll have time for about one more question before we wrap up. So Jason, this one is also for you. Can you share your thoughts on options to migrate current 30 terabyte Oracle on-premises database to PDF cloud, export, import, migration, or backload from scratch?
Yeah, that's another great question. So there's really a few options. So if you're an existing PDF customer, you know, we can always export and then import your existing database. It really comes down to what level of data discipline you have and how mature the deployment is. You know, oftentimes I say that this is a rare opportunity to hit the reset button and really revisit the integration and make any changes or corrections, take advantage of new features and enhancements that perhaps you weren't able to leverage because of legacy baggage with respect to your data integration. So my guidance is always, you know, if you have the source files and your integration isn't perfect, you know, now's the time to go back and make those enhancements and really get the most out of your data in the big data platform.
Thank you, Jason. And we've had a ton of great questions come in. Unfortunately, we don't have time to get them all, but we will respond to other attendee questions offline. So with that, thank you, Jason, John, Matthew, and Glenn for presenting today. And thank you everyone for attending today's webinar on smart manufacturing in the cloud. If you have
Great.
any other questions, please email them to info@pdf.com. Once you leave today's webinar, you'll receive a survey on the presentation, and we'd appreciate if you would complete that and provide your feedback. You will also receive a follow-up email within 48 hours with a link to view the recording of today's webinar. On behalf of PDF Solutions and our guest speakers from Graphcore and Skyworks, thank you for joining us today and have a great rest of your day.